You are most welcome, ladies and gentlemen, to Tuesday Night Anatomy with Daniel Okwan. Today's section, I take you through another section of the power behind the voice. My friends, yes, oftentimes, yes, students find it a bit difficult, to comprehend the concepts as far as organology is concerned. Yes, mainly talking about these internal organs, yes, largely derived from, of course, endoderm. So my friends, it is my job as the noted anatomical prophet, yes, to demystify some of these concepts for you. Now, today's meeting, I take you through the introductory bits as far as the histological aspects of luminal organs, yes, is concerned. Yes, in our next session or so, I'll be talking about that of compact, yes, or parenchymal organs. I will take you through that one also. So my friends, one thing that often, yes, even anatomy educators find it difficult to bring out the disparity is that they talk about this concept and then they talk about the fact that we have tubular and of course hollow organs. We use them interchangeably. But my friends, I want you to know that there's a thin line between these two guys. And my friends, at the end of this meeting, I expect you to use the right word. Otherwise, hollow or tubular organs, so-called, we will put them under something we call luminal organs. So my friends, without wasting my time, let's set the ball rolling. So there we are. Now the first thing, looking at this, yes, picture over here, it tells you about something. Yes, you can see that there's more or less like a tube. And one thing, unique thing that we find is that there's a central cavity. This white empty space over here is our central cavity. And my friend, this central cavity is something that we call lumen. So this lumen, the plural form of lumen is lumina. And my friends, you can see that this lumen is enclosed, by some kind of wall around this organ, so to speak. And so whenever I talk about luminal organs, first of all, one of the things that they are going to feature is that they will have a central cavity, and that's the lumen. Number two, that lumen, yes, will be surrounded by what we call the wall, of that organ. And my friends, at the end of this meeting, we will see what will be the tunics that will form the wall of this organ. And whenever I talk about tunics, yes, we can also call it coats. And sometimes some other authors will write it as layers of these organs. Now I'm going to take you through all these things so that everything about it, you understand it. So that's the first thing. Now sometimes you will see that these luminal organs, you will see that sometimes they will be having something we call, mesentery. For instance, those who dwell in the abdomen, they will have something we call mesentery, which will attach these organs to what we call the posterior abdominal wall. And one thing is that it's going to help them to become mobile, by way of giving them that kind of support. And then also through some kind of, there will be some kind of, neurovascular structures, reaching the substance of this luminal organ, through the same thing which we are calling it mesentery. So we'll be going through these things. And whenever usually the organ will have a mesentery, usually because it's found itself in the body cavity, then it will be having something we call mesothelial lining, something that we will be calling it serosa or serous layer. So I'll be taking you through these things. So that's the first thing, having a central cavity by way of lumen, and then having wall, which will be having tunics or layers. First of all, I'll tell you that the walls that it will be having, generally we have three of them. It will be having from the lumen, to the external aspect. We'll be having something we call mucosa. Then we'll be talking about muscularis, and finally, we'll be talking about adventitia or serosa. Now, don't forget, I told you that some of them will be having what we call the, mesentery, which will be attached to the posterior abdominal wall. In such a case, such ones will be having serosa instead of adventitia. So whenever you have the organ to be mobile, then usually it will be having serosa. But if they have the organ fixed to neighboring structures, then it will be rather be having adventitia. My friends, I'll be taking you through all these things. So first of all, let's look at this. Now, this is the confusion I want to clarify. That sometimes we say tubular or hollow organs. No, there's a difference. Although the general plan will be the same, but there's a difference between them. So for instance, if you look at this, an organ from the postpharyngeal guts, this guy is the stomach. When I go a bit cranial, I see the esophagus. When I go a bit caudal, I see the duodenum of the small intestine. In that manner, I'll go to a large intestine and so on. Now, one thing that you see is that this one, yes, has the feature of a tube. Really That's a tubular organ. So for instance, the esophagus becomes a tubular organ. Likewise, the duodenum also becomes a tubular organ. But my friends, the stomach is not a tubular organ. It's rather a hollow organ. It becomes dilated, so you can see it's very dilated, becoming this mango shape or J-shaped structure that we find over here. So morphologically, whenever the organ becomes hollow, it has functional implications. Usually the tubular organ, then the content will just move downwards straight without spending much time in here. But whenever the organ becomes hollow, then it means more time will be spent, okay, in that, organ, hollow organ. Okay, so for instance, we have what we call chyme. Okay, so the bolus of food all the way swallowed, okay, in the esophagus will reach the stomach. And when it gets there, through that kind of mechanical churning action of the wall of the stomach, because we will see something also, that the stomach will deviate from general plan of the organs of the postpharyngeal gut in the sense that it will be having 3 muscle layers. Normally, we expect to have what we call inner circular muscle and outer longitudinal muscle for organs of the postpharyngeal gut. That's the tubular organs, that's what I'm talking about, hollow organs. But in the case of the stomach, okay, because of how it is shaped, and it has a functional rule, that is to mechanically digest the food, okay, turn it into chyme. So it really is going to have a morphological, significance, being J-shaped, being dilated. That's one thing. I want you to know that. Yes, likewise, if I go to the urinary system, I also see that I'll be having, for instance, these are the ureters. These are tubular organs, okay? And then also, when I go downwards over here from the urinary bladder, I see the urethra. Okay, that's also a tubular organ. But my friends, look at it. This is the urinary bladder. It becomes dilated, okay, at this point. Has a functional implication by way of keeping the urine for some time before you, of course, you take it out of the body. Okay, so that is, one thing I want you to become aware of. And so this is what we call the urinary bladder. It is a hollow organ and not a tubular organ. Yes, likewise, if you look at this one, for instance, if I look at the uterine tubes, okay, these are tubular structures. If I look at the vagina, it's a tubular structure. But my friends, if I look at the uterus, it is a hollow organ. Why? Because the contents by way of the conceptus, okay, will have to be kept in here for quite a long time compared to the other areas. Okay, that's what I'm trying to tell you. So these ones become what we call, the uterus or the womb becomes hollow and not tubular, unlike, of course, the uterine tubes and, of course, the vagina. But if you look at it, the caudal portion, okay, of what we call the uterus, okay, is the cervix, which is, yes, also a tubular structure. Okay, that is one thing I want you to know. But of course, the main body, okay, of the uterus is going to be a hollow structure. Yes, I don't need to forget about this guy in the cardiovascular system. One thing that we see that we have blood vessels, okay? So we have the arteries, we have the veins, we have the capillaries. And my friend, don't also forget that if we talk about the circulatory system, we also include the lymphatic system. So the lymphatic vessels, they are also tubular. But my friends, if I talk about the heart is not a tubular structure. Rather, it is a hollow structure. Why? Because it becomes dilated at a point. That's what you can see over here. So that the blood that is flowing through it will spend a bit more time here compared to the other vessels that we are talking about over here. So my friends, having seen this, then what is the point? Whether it is hollow or tubular, once it belongs to a particular system, then the general plan remains the same. Yes, almost the same. That's one thing I want you to become aware of. Now, to explain this concept to you, first of all, think about it. Now, this is your skin. The skin is made up of 2 components. Yes, it's one thing that everyone is aware. Yes, even at the senior high school, whatever, you are told these things. That the skin is made up of, 2 components. And what are these 2 components we are talking about? The first of all, the most apical, the most superficial one. Okay, so this is the one that we call epidermis. Okay, so now whenever we talk about epidermis is made up of stratified squamous keratinized epithelium. Stratified squamous keratinized epithelium. And whenever we talk about stratified squamous keratinized epithelium, then it tells me that, yes, invariably, the skin that we find over here, okay, that is thin skin, there will be hair. By the way, for thick skin, there will be no hair. But one thing that we'll be finding is that we'll be seeing sweat glands over there. We'll be seeing sebaceous glands. Okay, yes, these are the things that we'll be seeing. Okay, so you'll be seeing sweat glands, you'll be seeing sebaceous glands. Okay, but the hair follicles, in thin skin, you will see hair follicles. But of course, in thick skin, there will not be any hair follicle. So these things, I want you to become aware of these things. Now, if you've seen that deep to wet, now remember that epithelial lining, and for that matter, epidermis, will be avascular. There will not be any blood vessel over there. So then the question is, what is supposed to happen? And that is why by principle, whenever we have an epithelial lining, deep to wet, there will be lamina propria, yes, of loose connective tissue. Okay? And of course, even below that, there are some areas that will be having dense irregular connective tissue. So generally, beneath the epithelium, there is going to be connective tissue. Okay? Because in the connective tissue, we have blood vessels, we have lymphatic vessels, okay, other nerves and all that, okay, around. So that they can give nourishment to the cells of the epithelial lining, and also to take away the wastes. Okay, giving a support, whatever support that we are talking about. So now, what are the things? So that this connective tissue which is beneath the epidermis is the one we are calling dermis. So whenever we talk about the skin, we say that the skin is made up of epidermis and of course the dermis. The epidermis is simply the epithelial lining that is stratified squamous keratinized epithelium, and then deep to it, the connective tissue is the one we are calling dermis. Okay, so that is one thing. Now, when we talk about skin, there are other synonyms for skin. So the skin can also be called integument. Okay, you can also call the skin cutaneous membrane. But my friends, as far as the concept of, today's section is concerned, yes, I want you to know about this, that the skin is also known as cutaneous membrane. Okay, now, if we are talking about the skin to be cutaneous, now look at it from here, cutaneous membrane, then it goes in there. So for instance, it continues with that of the oral structures. Yes, if you go down there, anal canal, whatever, okay, if whatever reproductive structures, if it is, the urinary structures, or respiratory structure, they will be continuous with these structures. Now, when we get there, we won't call that area cutaneous membrane. Rather, we will call it cutaneous. Rather, we call it mucous membrane. Mucous membrane. So please look at this one. So now that's what I'm trying to say. That the skin is over here, is having its epithelial line, a stratified squamous keratinized epithelium, and then deep to it we have what we call the dermis, okay, over here. That's the skin. And the skin is the one we are calling it cutaneous membrane. Now, if I look at the counterparts, okay, for instance, the oral structures, that one we don't have skin, but rather we're having mucous membrane. The name will change, okay, to mucous membrane, okay, contrast with these internal structures. So, for instance, we will be having the epithelium. For instance, this is in the case of the oral cavity, wherever, okay, it could be the esophagus, it could be the anal canal, it could be the vagina, it could be the uterus, wherever you find it, rather we'll be calling it mucous membrane. And that mucous membrane also will be made up of epidermis, made up of an epithelial lining, okay, and of course, connective tissue. Okay, so that was one thing I want you to know. And my friends, this epithelial lining together with the connective tissue is what we are calling the mucous membrane. Now, my friends, I want you to know, simply this mucous membrane can be called mucosa. So whenever you hear of mucosa, we are still talking about the mucous membrane, which is made up of two things, an epithelial lining and of course the connective tissue. But my friends, one important thing I want you to know is that this connective tissue, as I told you, will be well endowed with blood vessels, okay, lymphatic vessels and other components which of course will help, okay, nourish this kind of epithelial lining. So my friends, for this reason, it becomes the more important component of what we call the mucosa. So for this reason, we call this connective tissue lamina propria. So my friend, whenever you hear of lamina propria, we are talking about a proper layer, okay, which is having a lot of the nourishment, okay, components, okay, and that one together with the epithelial lining, all four, of course, this mucosa we are talking about. So that's the useful thing I want you to know, okay, regarding this area. Now, having seen this, now generally, if you say tubular or hollow organs, they will have a general plan. As I told you, that one will be a general plan. So now the first thing, we've seen one of the tunics. So from the lumen, if this is the lumen, okay, then we are looking at the wall. What are the tunics that form the wall of these tubular or hollow organs? Now from the central point by way of the lumen, and as I go externally, what are these tunics? Generally, luminal organs will be presented with three tunics. And as I mentioned, Okay, you have what we call the mucosa, then we go into what we call muscularis, and then eventually we go into adventitia or serosa. But sometimes you may see that there will be some variation. So let's look at this one. So if you look at the mucosa, as I told you, it's made up of epithelial lining, and of course deep to it, we'll be having what we call lamina propria. Okay, that's all. But my friends, the point here is that in the case of organs of the postpharyngeal gut, yes, this is an important statement. In the case of organs of the postpharyngeal gut, and whenever I talk about organs of the postpharyngeal gut, my friends, I'm talking about the esophagus, the stomach, the small intestine, of course, the large intestine. These organs, rather, their mucosa will be having 3 layers. So normally, mucosa will be made up of 2 layers, an epithelial lining, and of course, lamina propria of connective tissue, actually loose connective tissue. But my friends, in the case of organs of the postpharyngeal gut, they will be having 3 layers. And that is, of course, the epithelial lining, there will be lamina propria, and of course, there will be an internal muscle layer. And that is something we call muscularis interna. And because that muscle belongs to the mucosa, we give it another name, and that is muscularis mucosae. Okay, so I want you to appreciate that. And my friends, whenever we talk about muscularis mucosae, it is exclusively made up of smooth muscle fibers only. And your muscularis mucosae will present with 2 layers, okay, an inner circular layer and an outer longitudinal layer. And my friends, one thing that we find is that normally under light microscopy, we don't see the inner circular layer, we only see the outer longitudinal layer. But my friends, again, in the case of the stomach, even under light microscopy, we see that of this muscularis mucosae. So as I said, the organs of the postpharyngeal gut will be having it. And one thing that will be seen is that this muscularis mucosae will be thinning out, okay, beyond the level of what we call the stomach. So one thing is that the muscularis mucosae is very prominent in the esophagus. Okay, of course in the stomach also, because that one we can see the 2 layers even under light microscopy. Then it begins to thin out, okay, from the small intestine by way of duodenum, okay, jejunum, ileum, okay, it gets to, of course, the colon. And whenever I mention colon, remember that histologically it includes the cecum, okay, gets to the rectum. But my friends, beyond the anorectal junction, we don't see the muscularis mucosae again. Okay, so it means that the anal canal, although it's an organ which belongs to the postpharyngeal gut, it is devoid of muscularis mucosae. I want you to appreciate that one. I'm going through the other things as we get there. Now, from there, once we move out from the mucosa, then we go to what we call muscularis. But my friends, one thing I want you to know is that also again, for organs of the postpharyngeal gut, we don't move straight forward from mucosa and then we go to muscularis. There's another tunic, and that's, my friend, the guy over here, which we call a submucosa. It means there's another tunic over there which we recognize in organs of the postpharyngeal gut that also have a submucosa. And my friends, the submucosa, it is also made of connective tissue. But this time around, it is not loose connective tissue areola, but my friends, it is dense, irregular connective tissue. Dense, irregular connective tissue. My friends, I've been talking about epithelial line, I've been talking about connective tissue. I have several videos. Yes, if you get to my histology basic tissue playlist, you get all those things there. Now, I'm not going to take you through that one today because, I've done videos on these ones. Okay, so that is what we call the submucosa. Okay, now, one thing that we know is that this submucosa, okay, relatively, it may be thicker, okay, sometimes it may be just smaller. But one other thing too is that it is not only organs of the postpharyngeal gut that we find submucosa. That's another important thing. But my friends, also organs of the oral cavity, some of the organs of the oral cavity. Okay, so for instance, I talk about the lip, I talk about the cheek, okay, I talk about, for instance, the soft palate, okay, I talk about the tongue. They will be having what we call, submucosa. But my friends, not the hard palate, and of course, not the gingiva. Whenever I talk about gingiva, I'm talking about the gums, okay, which I actually tell the teeth. They will not have a submucosa. My friends, why? For those ones, they are fixed, okay, to either bone or to the teeth. Okay, so those ones will not have a submucosa, and they are highly non-mobile. Okay, so that is one thing that we want to know. Now, normally, if you look at these oral structures, if you want to see glands, and we talk about which glands, we are talking about salivary glands. We want to see the salivary glands dwelling in the submucosa. But as I said, for organs of the postpharyngeal gut, you will not be seeing the glands in the submucosa. Normally, you'll be seeing the glands, as you can see over here, in the lamina propria. And whenever we talk about glands, we are talking about the downward route, that localized proliferation of the epithelial cells which go downwards, okay, into the convolution area, so that we will have what we call a distal secretory portion, okay, that becomes a sinus, okay, secretory sinus, and of course the proximal duct to convey the product onto the surface epithelium. Okay, that is one thing I want you to know. Now, for instance, in the case of this one is the stomach, the duct is given a special name, and that's what we call gastric pit. So, my friend, whenever you hear of gastric pit, we are talking about the duct, okay, of the gastric gland. Okay, that's the proximal portion of what we call the gland of the stomach, okay, gastric pit, to convey the product onto the surface epithelium. Good. Now, is it only the oral structure which will present with the submucosa and that of organs of the postpharyngeal gut, my friends? No. Even when we look at the respiratory tract, when I talk about a trachea, when I talk about the bronchi, okay, whether it is, of course, intrapulmonary or extrapulmonary bronchi, they will also present with what we call a submucosa. And normally these submucosa will be seeing glands. Let me be quick again and come back. For organs of the postpharyngeal gut, normally, as I said, we want to see the glands in the lamina propria, okay, of the mucosa and not in the submucosa. But my friends, sometimes you may be seeing glands in the submucosa. And whenever we have such a phenomenon, it becomes diagnostic to help us identify some of these areas. And so one thing is that, number one, at the upper portion of the esophagus, yes, even some authors have reported that throughout the entire length of the esophagus, okay, what we'll be seeing is that intermittently, okay, you'll be seeing glands, okay, in there. And one other thing too that I want you to know is that there's another area, and that is what we call the duodenum of the small intestine. So the duodenum will also be presented with glands in what we call the submucosa. And whenever it happens like that, it becomes diagnostic. Now, because we don't expect to see glands in the submucosa and these two areas, the upper portion of the esophagus and then also the duodenum, then one thing that we say is that these glands, we qualify them with the word proper. So whenever I mention esophageal glands proper, then I'm not talking about the glands which are in the lamina propria, but my friends, I'm talking about the glands in the submucosa. Also, when I talk about duodenal glands proper, then I'm not talking about the crypt of Lieberkühn, which are the glands in, of course, the lamina propria of the duodenum, for instance. But rather, I'll be talking about that glands in the submucosa, and which is often given an eponym Brannus glands. Okay, so that is one thing I want you to know. So we may have a submucosa also. Then from there we go to that of, so submucosa, we don't see it everywhere. These are the exceptional cases that we see in submucosa. Okay, so that's one thing. Now from there we go to that of what we call muscularis. We go to muscularis. And so for organs which do not have a submucosa, we straightforward call it muscularis. But for organs, okay, of the postpharyngeal gut, which already I told you that there will be one muscle layer over here, which is exclusively made up of smooth muscle fibers by way of muscularis mucosae. This guy over here will have to be qualified with the word externa. This one was muscularis interna, that's muscularis mucosae. So this one will be called muscularis externa, or that's actually the proper muscle we want to see. And that's why we call it muscularis propria. Okay, so that is one thing that we see. Now for organs of the postpharyngeal gut, one thing we see is that this muscularis is differentiated into two, the fibers. Okay, there's that kind of disposition of the fibers, such that we see that we have inner circular, just like the muscularis mucosae, and of course outer longitudinal muscle layer. That's what we see. Okay, and then we'll be seeing some kind of nerve plexus. I'll be taking you through that one as we move along. Okay, so that is one thing that we see. Now, oftentimes people get confused with some of these things. As we move along, I'll be showing you this. Now, if you look at this circular, you can see that this is broken up into pieces. Something often I see that the muscle fibers are continual, or they are moving intermittently. Because we can see some spaces, and of course we can see some substantial connection running through them. Okay, that's what we see. But if you look at this one, it's like the fibers are continuous without really a break. So we say they are continuous, or the muscle fibers have not been disturbed. That's the one we see. So some people think that whenever they see the muscle fibers broken up in pieces, that's the circular component. And whenever it is continuous, like that's the longitudinal component. My friends, no. It depends on the plane of section. Now, for instance, if you look at this one, the circular is broken up into pieces because this is a longitudinal section. Now, if you take a longitudinal section and the muscle fibers are running, okay, circularly, then what is going to happen? You'll be cutting against the orientation of the muscle fibers. And when that happens, you'll be seeing them to be broken up into pieces. However, if the muscle fibers are moving longitudinally, okay, and then of course you also cut longitudinally, then you are cutting in favor of the orientation of the muscle fibers. In such a case, the muscle fibers will be continuous. They will not be disturbed. However, if I do the reverse, rather if these ones are moving, okay, circularly, and I cut transversely, then these ones will not be disturbed. They will look like that we see for the longitudinal. And then that of longitudinal will be looking like that we see for the circular. Because if you cut transversely, then the orientation of the muscle fibers which are going longitudinally, yes, will be cutting across it, and therefore they will be disturbed. Okay, so that is one thing I want you to know. Again, one other thing I want you to become aware is that let this one becomes the reference point. So for organs of the postpharyngeal gut, there's a muscle disposition. So for instance, if I go to the urinary system, okay, I will see the reverse. So I will see that we rather be having an inner longitudinal, outer circular muscle component. And then also, sometimes this muscle will be having 3 layers. So for instance, as I mentioned, the stomach rather will be having an inner oblique. Okay, so that's the one you see over here. We'll be having an oblique component, inner oblique, a middle circular, and of course an outer longitudinal muscle component. Yes, because of its role that is playing. Likewise, if you look at that of the urinary bladder, okay, because of how it appears, okay, serving as a reservoir for this urine for some time, okay, then what is going to happen is that it will also be having an outer, this time I take attention to this one, it will be having an outer longitudinal, middle circular, and inner longitudinal component. Okay, so that is what we'll be seeing. We'll be seeing some of these, although under light microscopy you don't see these things distinct. That's in the case of the urinary bladder. The detrusor muscle appears to be ill-defined. Okay, that is one thing I want you to know. One more thing I want you to become aware over here is that these muscles, okay, may have functional implication. So for instance, for organs of the postpharyngeal gut, one thing that we see is that the inner circular, okay, will be useful as far as peristaltic contraction is concerned, and then also to form sphincters to guard the opening of, you know, some of these other areas of the organs of the postpharyngeal gut, to form sphincters, and of course for peristaltic contraction. While the outer longitudinal will be relevant as far as something we call segmental contraction is concerned. But my friends, one useful thing is that working synergistically, the inner circular and outer longitudinal muscle layers will be useful, okay, in something we call propulsion, so that the food product can be moved from one segment to the other. Okay, so that is one useful thing. Now again, for organs of the postpharyngeal gut as a reference point, one thing we see is that usually the muscle infiltration in the connective infiltration in the muscle is limited. It's not that prominent. But my friends, I want you to know these systems: the urinary system, the male, and of course the female reproductive systems. What we see is that the muscularis, okay, gets high infiltration of what we call connective tissue. Okay, so it becomes diagnostic. So once you are seeing a lot of connective tissue in the muscularis, then it tells you that, of course, this is what we call, this is likely going to be either the urinary system, it's going to be, of course, the male or the female reproductive system. I'll talk about this one because between the inner circular and, of course, the outer longitudinal, you may see a nerve plexus. And this, because we are talking about muscle, we call it myenteric nerve plexus, who is often given an eponym. Yes, that's the Albers nerve plexus. Well, I've done these videos. In the submucosal too, you may be seeing a nerve plexus, and that's something we call the submucosal nerve plexus or Messiness nerve plexus. These ones, I've done these ones already. And then, of course, the outermost tunic, and this is very important, please pay attention here. The outermost tunic is something we call adventitia, or sometimes it could be serosa. So now the question is, what is the distinction? Whenever it is adventitia, then it is made up of only loose fibroelastic connective tissue, only loose fibroelastic connective tissue. And such organs, the idea is that, those organs, they become immobile, they become fixed. Why? Because their connection is to glue this organ to neighboring structures so that it becomes immobile. Okay, so that's what we see. And because it grooves with neighboring structures, then what happens is that the connective tissue of these neighboring structures blends with it. So apparently, if it is going to be adventitia, you see that this outermost tunic, okay, becomes substantial. However, when it is serosa, for the case of serosa, you'll be having loose fibroelastic connective tissue, and lining the outermost, you'll be seeing simple squamous epithelium, and that is something we call mesothelium. Okay, and this mesothelium, one thing that is going to do is that it will secrete, okay, some glycoproteins. Yes, some may also be rich in surfactants, okay, to ensure that there's limited friction, okay, so that the organ will become mobile. Okay, so that is one thing I want you to become aware of here. So these are the general things that generally you'll be having mucosa from the lumen to the external aspect, mucosa, muscularis, and of course adventitia. Some of them may have, submucosa, and then also some of them, once there is a muscularis mucosa, that's in the case of organs of the postpharyngeal gastric I mentioned to you, those ones, the muscularis will have to be qualified with the word propria or externa. Yeah, so now one thing is that if you talk about mucosa, why do you think we need the lamina propria? As I've already explained to you, that the lamina propria be well endowed with blood vessels. Okay, and so you can see. Now this one is actually coming from an oral structure, or it may also be coming from the esophagus or the anal canal, or even if you look at, yes, my oral side like the lip, sometimes we say that, this area that we apply the lipstick, okay, it becomes pinkish. Or sometimes we say that is the red zone, okay, the Babylon zone. Now, this area, for instance, you'll be seeing that for stratified squamous, these areas will have stratified squamous non-keratinized, or sometimes they may be keratinization, pra-keratinization over there. Okay, what we'll be seeing is that if some line where you stratify squamous, whether it's keratinized or non-keratinized, we'll be seeing these things. And my friends, these things, they are what we call the epithelial pecs. So that kind of indentation. When we see the epithelial lining, okay, invading the territory of the connective lamina propria, these things, they are what we call epithelial pecs. Something we can also call epithelial ridges. Now, if it's the skin, then we call it epidermal ridges or epidermal pecs. Okay, so that is one thing I want you to know. Now, always I talk about Newton's third law of motion. And Newton's third law of motion tells us that actions and reactions are equal and opposite. So for this reason, because the epithelial line couldn't confine itself to its L3, but invaded that of the lamina propria, the lamina propria also invade. So that's what we see. And so for this reason, these guys over here become something called connective tissue papillae. Connective tissue papillae. Or something you may also call retipex. Okay? So that's what we see. Connective tissue papillae invading it. And it's that connective tissue, that what I told you, that they will be well endowed with blood vessels. So for instance, if the epithelial pecs, if the connective tissue papillae goes so high towards the epithelial lining, okay, then what will happen is that the area becomes more reddish or more pinkish. So assuming the blood vessel reaches this point, then it means because this area is so thick, the blood is not able to reach this area to give it that kind of pinkish appearance. But because this one is able to reach a very high extent over there, then the epithelial lining appears pinkish. Okay, so that's one thing I want you to do. So all that I want you to know over here is that the lamina propria is supposed to give nourishment, okay, through diffusion across the non-cellular basement membrane, separating the epithelial lining, of course, and the lamina propria. Okay, so that's all I want you to know. Yes, already I've talked about this one, that yes, we have adventitia, and adventitia will be made up of, yes, only loose fibroelastic tissue. But if it is an organ, that, of course, will be having a mesothelial lining. Okay, for instance, if it's the lung will be covered with visceral pleura. If it's the heart, it will be covered with what we call the visceral layer of serous pericardium. If it's an organ, an peritoneal organ, okay, like the stomach, like the jejunum, okay, like the ileum, okay, these ones will be having what we call a mesothelial lining. And that mesothelial lining, you see simple squamous epithelium lining the area. And whenever you have mesothelium, it serves as a delimiting structure so that this organ doesn't blend with any surrounding structure. And so usually, whenever you are going to see serosa will be relatively thinner compared to adventitia. But adventitia is simply connective which blends with neighboring structures. So apparently, the outermost tunic over there will be larger, unlike in the case of serosa. And so what are the areas that I mentioned that you'll be seeing the serous membrane? Okay, so that we'll be seeing simple squamous epithelium lining the area. So that instead of adventitia, we'll be seeing serosa. Which are these areas? Yes, I've mentioned the heart, okay, because we have in the visceral layer, visceral layer of what we call serous pericardium over there. Also the lung, the visceral pleura will also be there. So if you cut the outermost, we'll be having simple squamous epithelium over there. And then also, in these intra-abdominal organs, like the liver septic bay area, I've mentioned the stomach, I've mentioned the jejunum, the ileum. Okay, we've mentioned now not entirely every part of the large intestine. Actually, the transverse colon. Okay, of course, talk about the appendix. Okay, talk about the sigmoid colon. They will be having these things, not the entire every portion of the large intestine. Okay, so that is one thing I want you to become aware of. The remaining ones will be having adventitia. Now, one other thing too that comes into mind, look at it. I said that the liver will be having, now if you look at it closely, you can see this blue area all around the liver, except this area. This area is called the bare area of the liver, where instead of having a mesothelial line, no, we don't have it. So straightforward, it's only connective tissue that we find over here. Why is it so? Because what we see is that the peritoneal line and covering, the serous peritoneum will undergo something called zygosis, because it blends with the diaphragm over here, and therefore, yes, it goes away. That's one thing I want you to know. Now, just to take you through just a few of these things, if you look at that of the esophagus, what do we see? The epithelial lining, yes, you can see it is stratified squamous, non-keratinized epithelium. And then, of course, if you look at the lamina propria, okay, before I even go to lamina propria, yes, there's lamina propria over here. That's what we see. And then you can see some muscle where it's broken up into pieces. If you take a closer look at it, it's broken up into pieces. That's under hematology, the eosin stage, so you don't really distinguish between these ones so much. So this broken up into pieces muscle that you find over here is the one I mentioned to you. That's the muscularis mucosa, telling me that is an organ which belongs to the postpharyngeal gut. Okay, so that is one thing I want you to know. I've done videos on these ones. Okay, you can get a full video. Okay, get my playlist of histology of body organs, and you get these things to watch. But what do I see? I said I usually want to see glands in the lamina propria, but of course, in the upper portion of the esophagus, you don't see glands in the lamina propria. It's only the terminal portion of the esophagus, okay, where it goes and meets that of the cardia of the stomach, and that is why the glands over there, we call them esophageal cardiac glands. Esophageal cardiac glands. They are over there, but we don't see it over here. And usually because this closer to the upper portion. But in the upper portion, you'll be seeing, okay, glands rather in the submucosa. So below this muscularis mucosa, you'll be having glands over here. And so this area that you find over here is actually the submucosa. Is the submucosa that you are seeing over here. Alright, so that is great. And of course, you go to the muscle and all that. That is one thing I want you to know. Yes, there are other things. For instance, organs of the postpharyngeal gut, you may be seeing something we call mucosa. Not only organs of the postpharyngeal gut. Whenever you have mucosa, because they communicate with the external environment, okay, then they need some kind of immune support. Okay, so they may be having something we call either diffuse or dense, okay, lymphatic tissue. And one of them, okay, because it's associated with the mucosa, we are calling it MOT, mucosa associated lymphatic tissue. But whenever it's associated with the gastrointestinal tract, and for that matter, the gut, then we call it gut-associated lymphatic tissue. Okay? And one thing which becomes very diagnostic, for instance, in the case of the appendix, you see that in the lamina propria, we see that these things which you find over here, which you call them lymphatic nodules, all move around the entire wall of what we call the appendix. But in the case of what we call this, in this case, this is the ileum, what we see is that they get confined at one point. Okay? At an area we call the active mesenteric border. Okay? And that one becomes diagnostic for us. Yes, these ones, when they are juvenile, they confine themselves to what we call the lamina propria, but as they grow, they enlarge and of course they break through the muscularis mucosae to enter the submucosa. Okay, so that is one thing I want you to know. And so many things, some of them may be just solitary, just one over there, and some of them may be diffuse, okay, simply lymphocyte spread in what we call the lamina propria or even the submucosa. As I mentioned, between the inner circular and outer longitudinal, usually we talk about the gut of the brain, we have the enteric nerve plexus. Okay, so that enteric nerve plexus for the gastrointestinal tract, we see two main things I want you to know, which of course in the developmental anatomy bit I explained to you, that they will arise from what we call the neural crest cells, the 4J layer. Okay, and who are these guys? Between what we call the inner circular outer longitudinal muscle layers, we see one of the nerve plexus, I've mentioned it to you. That's of course the mesenteric or the obverse nerve plexus. And of course, in that of what we call the submucosa, we see what we call the submucosal or Meissner's nerve plexus. But the point is, what are their functions? The function is that, for instance, let's move. Yes, this is actually the obverse nerve plexus. So the obverse nerve plexus is found between the inner circular outer longitudinal muscle. So what is the rule? Is to ensure that these muscles can contract, okay, ensuring the peristaltic and of course the segmental contractions to aid, of course, eventually in that proportion of the food content. Then when I come to the Meissner's nerve plexus, what is it supposed to do? Yes, it's going to supply the muscularis mucosae because it's so close to it. It's going to supply the muscularis mucosae, and not only that, also the glands that we find in, of course, in case there's some glands in the submucosa, give it that kind of supply to it. Now, one other thing to it that, for instance, if I look at organs of the postparietal or some other places, you may be seeing folds. Yes, normally we talk about more of them in the organs of the postpharyngeal gut. Okay, so for instance, I can talk about this guy that you find over here. Okay, because these are villi. Now, if you say villi, remember that I've explained microvilli, branch border, striated border in the previous video to you. Now, this guys, these finger-like or tongue-like, leaf-like things, I've mentioned it to you, where it's formed by a tail line, and of course, lamina propria, is something we call villi. Okay, and one thing we know about villi is that villi will increase absorptive surface area by a factor of 10, while of course microvilli will do so by a factor of 20. Then we can see over here another fold formed over here, this whole thing, and the core for this fold is a submucosa. Okay, so whenever I talk about this particular fold, which we also call a valve of Kerkrin, or we call it plaque secularis, okay, it is made up of the mucosa and of course submucosa. That's all. So what are these are permanent folds that we find over here. This one, which we call plaque secularis, also increase absorptive surface area, but this time by a factor of 3. If I look at that of the stomach, we'll be talking about rugae. So rugae, we won't see villi, we won't see goblet cells in the entire lining. We'll be having simple columnar epithelium, okay, and then we'll rather be having what we call rugae, and that rugae will not increase absorptive surface area, will allow for expansion. Okay, as I mentioned, okay, once you begin eating and the stomach gets filled with the food, they get ironed out, okay, so that you don't see them. So the role of the gastric rugae is to accommodate increasing, okay, content in the stomach. Okay, I can also talk about the plaque transversalis recti, which are the transverse rectal folds that when you find it in the rectum, also made up of mucosa and submucosa. Those ones are permanent folds. Okay, I want you to appreciate that. Now, it doesn't mean that we don't find folds anywhere. We have so many folds. Only that, yes, the esophagus will have folds because whenever there's no food running to it, get collapsed. But those ones are temporary. But what the point is that we're not giving them special names. Okay, that's why we talk about these main ones. Yes, if I look at the urinary bladder, okay, the urinary system actually, as I mentioned, we will be having transitional epithelial line. There's a lumen, transitional epithelial lining. I've done these videos already. And then deep through there will be lamina propria forming the mucosa. There will not be any submucosa, but straightforward we go into muscularis. And this muscularis, as I mentioned to you, normally we having inner longitudinal outer circular. This is actually taken from what we call the distal 1/3 portion of the ureter. Now the ureter, for instance, is divided into two areas, proximal 2/3 portion and distal 1/3. That's actually from the distal 1/3. And as I mentioned, because the urinary bladder will be made up of, theoretically, urinary bladder will be made up of inner longitudinal, middle circular, and of course outer longitudinal. We see the features similar to this one. So we can see some of the fibers over here are broken up in pieces. There's a transverse section, as you can see over here. So the fibers that we find over here are broken up in pieces. I have another area where the fibers move smoothly. Then I have another area where the fibers are also broken up in pieces again. So it tells me that there's inner longitudinal, middle circular, outer longitudinal. That's what we see. I just want to show you this one. And this one will have substantial, so it goes all the way. So this having adventitia instead of serosa. So it goes all the way because it's blended with other neighboring things. There's no delimiting mesothelial lining. Okay, so that's one thing I want you to know. Yes, likewise, if I look at this guy over here, which is of course show you that of the blood vessels that we find over here, I can see blood vessels will be made up of 3 things, just like that of the urinary system. Okay, so from the lumen to the external aspect, we'll be having what we call mucosa, muscularis and adventitia. But in the case of blood vessel, the mucosa is given a special name, and that mucosa is called tunica intima. Because the blood will be running intimately within this area over here. So it's also called tunica interna. Okay, I mean these are the things, and then of course we'll be having what we call the tunica, media for your muscularis, and then the outermost tunica adventitia, or simply tunica externa. Okay, these are the things I want you to know. Yes, not only that, even if I look at the heart will be having endocardium, that's for the mucosa. It will be having what we call myocardium, that's for the muscularis, and then to be having what we call serosa, and that will be what we call the epicardium. Okay, so I want you to understand these things. If I look at the uterus for instance, the uterus rather be having, the mucosa will be called, endometrium, the muscularis will be called myometrium, and then of course the uterus will be having, that is draped in this, broad ligament, so it will be having mesothelial lining. Okay, so the serosa will be called, perimetrium. Okay, so I want you to become aware of that. So these are the major things I want you to appreciate it. Yes, I've done histology of the blood vessel. You can go and watch that video. Yes, finally, I've done video on this one too. That whenever, please, this is very important. Whenever you see that you have cartilage in the wall, yes, usually mainly talk about hyaline cartilage. Okay, once you are having this, then we are talking about respiratory tract. Because for the respiratory tract, most of these luminal organs will have to be made patent so that all the time air, even at low air pressure, can get to the lung eventually. So we'll be seeing, cartilage, okay, as a tunic or a component of that tunic will be there. So there's the lumen, and you can see the epithelial lining, pseudostratified ciliated columnar epithelium with goblet cells, something simply we call respiratory epithelium. Then you go to the lamina propria, and this one I can see some smooth muscle, consistent smooth muscle over here. Okay, I've done these videos already. And then of course I go to the submucosa where I can see glands in there. Okay, submucosal glands. And then I go to that of the cartilage tunic over here, which of course, whenever you have hyaline cartilage, there will be perichondrium. Okay, perichondrium all around it. And then look at this. This one I can see lung parenchyma over here. I can see this spongy-like appearance or foamy-like appearance, showing me the alveoli, alveolar sacs, alveolar ducts, and all that around over here. So it tells me, actually, this is actually from the bronchus. It tells me that there's an intrapulmonary bronchus and not an extrapulmonary, because for extrapulmonary bronchus, I will not be seeing the lung parenchyma. So my friends, I'm very grateful for your time this evening. This was just a quick overview, trying to make you appreciate the concept of luminal organs, that they will be having a lumen, and then they will be having that kind of tunics forming the wall. I'm very grateful for your time this evening. Have a good night, all of you, and may the good Lord richly bless you. Amen.